PL imaging, EL imaging, lifetime curves and lifetime imaging, QSSPC, IV SUNS, VOC measurements, implied IV measurements like VOC, current density, efficiency, and then defect quantification identification. And yeah, I'll just go through the images here. So these are the type of things we would be looking at each process step. So in raw wafers, and I'll go through this quickly, interrupt me if you have any questions. In raw wafers, we would be looking at general wafer quality. We'd be looking at center ring oxygen defects, inclusions, saw marks, etc. We'd probably be evaluating PL count. Moving on to textured wafers, we'd be looking at similar things, but also contamination from texture chemicals. Again, the second sample from the left here indicates an inclusion from oxygen ring defect that would show up in a finished cell. So that's something we'd be looking at the start of the process here. At diffusion, we'd really be looking at diffusion non-uniformity. You can see on the sample on the right, there's certainly struggles and contamination with gas movement in the furnaces. Things are not right there. Blotching is clearly occurring. That would be a concern. And we want to look at, again, furnace settings and whether gas was making its way around the entire furnace. Moving on, yeah. Selective emitter, again, we'd be looking at diffusion non-uniformity. We'd be also looking at selective emitter surface damage, scratching on the samples. Yep. And then, yeah, moving on, again, quickly through the process steps, pre-annealing process wafers. Here we'd be testing lifetime with our QSSPC function. We'd be looking at lifetime issues and probably building a catalog for lifetime here. And by the way, this is a PERC process, not TopCon, but the kind of things we'd be looking at would be similar until the process steps change. PSG, polished wafer. Here's a good example of us being able to see things through the entirety, through the last steps. Again, we'd be looking at particular things here, scratching, especially at this stage in the process, because the samples are so fragile. Improper sample processing, as I said. Passivation, bond quality, uniformity. Again, passivation, bond quality, uniformity on the front and the back. And then finally, at the printed solar cell, we'd be looking at a lot of different things with both PL and EL, metal quality, finger quality, uniformity, series resistance, etc.